Welcome to this preview of the course Reliability and Efficiency in Process Heaters offered by Arven Training and Engineering. This course was designed with two fundamental objectives. The first of them is to understand the extraordinary potential for energy savings and carbon footprint reduction of refinery process heaters. The second objective is to provide analytical tools and an evaluation methodology that can be applied by engineers and technicians to increase overall refinery performance and productivity while preserving the heater's mechanical integrity. The course has been conceived and developed by Mr. Euler Jimenez, who holds a master's degree in advanced chemical engineering obtained in the United Kingdom. His professional experience is concentrated in the areas of process heaters, combustion processes, and on-site and virtual training. Lesson 2 of this course addresses the topic of emissions and global warming. What follows in this short video is a sneak preview of some of the most important issues covered in this lesson. The use of fossil fuels is taken for granted in modern life. However, its production and consumption entail serious economic, environmental, and social impacts. The release into the atmosphere of carbon dioxide, nitrogen oxides, sulfur dioxide, and solid particles generated by combustion of fossil fuels constitutes a major concern as a cause of short-term atmospheric pollution, as potentially devastating pollution of land, air, and water resources in the medium term, and ultimately as a generator of long-term environmental impacts in the form of climate change. Fire heater operators, engineers, and refinery managers must understand the concept and causes of global temperature rising by greenhouse gases and how to address its consequences, which are becoming critical for the sustainability of life. Global fossil fuel consumption. Crude oil currently dominates the global fossil fuel market with approximately 54,000 terawatt-hours. Coal follows with approximately 45,000 terawatt-hours, and natural gas with approximately 39,000 terawatt-hours. Environmental impact. Pollution from natural sources includes volcanic eruptions, wind erosion, forest fires, release of methane gas, pollen, etc. Anthropogenic pollution is the one caused by men and refers to emissions associated with activities that involve, for example, the burning of fossil fuels in internal combustion engines or in industrial furnaces or refinery heaters, deforestation, and pollution associated with land use as livestock farming or man-instigated forest fires. Another form of pollution is atmospheric smog. Smog is a yellowish or blackish fog formed mainly by a mixture of pollutants in the atmosphere consisting of very fine particles and ozone. Atmospheric smog is formed by pollutants derived from vehicular and industrial emissions, forestry and agricultural fires, and other fossil sources. The greenhouse effect. Hypothetically, in the absence of the atmosphere, ascending radiation from the Earth would balance the incoming energy from the Sun with an average surface temperature of around minus 18 degrees centigrade or minus 0.4 degrees Fahrenheit. In contrast, and very fortunately, infrared heat radiation emitted by the Earth is absorbed into the atmosphere by greenhouse gases such as water, carbon dioxide, and methane. Greenhouse gases then exert natural thermal control on the planet, allowing more heat to be absorbed and re-emitted back to Earth and less heat to escape into space. This phenomenon of thermal control of the planet is called the natural greenhouse effect. Global warming is, more precisely, the long-term warming of the Earth's climate system observed since the beginning of the pre-industrial period in the mid-19th century due to human activities. These activities have increased considerably the amount of greenhouse gases in the Earth's atmosphere. Climate change. The consequences of increasing global atmospheric temperature are becoming critical for the sustainability of life on the planet. Some examples can be cited. Desertification, that is, the reduction in the biological productivity of arid and semi-arid lands, increased melting of glaciers and subsequent rise in sea level, the intensification of storms and other extreme events such as hurricanes, typhoons, floods, etc., and finally, the progressive acidification of oceans. Measures to mitigate climate change. Measures proposed by government agencies, private companies, academic institutions, etc. to mitigate climate change include establishing improvements in energy efficiency, the increased use of low-carbon energy, such as natural gas or carbon-free energy, nuclear, wind, and solar, the increase in carbon sinks, that is, in practical terms, less deforestation and more afforestation and reforestation to increase forests, the production of hydrogen from renewable sources, the production of biofuels from agricultural waste and/or non-edible crops, carbon sequestration, which involves the capture and underground storage of CO2 derived from the burning of fossil fuels, and carbon farming, for instance, reducing tillage. Tillage is soil mechanical agitation which contributes negatively to soil quality. The carbon budget concept defines the tolerable amount of greenhouse gas emissions that can be discharged during a specific time to avoid worsening the impact of climate change. The carbon budget for a 2°C world, as defined by the Paris Agreement, is the maximum amount of CO2 that can be released to maintain a 50% probability that the increase in the global average temperature of the atmosphere will remain below 2°C. Stranded assets and carbon budget. The carbon budget concept highlights the need to assume the cost of leaving around 2/3 of known fossil fuel reserves as stranded or unexploited assets to achieve global climate goals. This slide finalizes the Lesson 2 preview on emissions and global warming. You are kindly invited to check on our website for more information on course content as well as for engagement details. Thanks very much for your attention.